Now you mention your name in chat box. I'm going to share the slides. Everyone should have to mention your name in chat box as a presentee. Okay, so we are here and we are going to be understand the remaining concept about the photochemistry. So for that, in the last lecture, we on this slide. Okay, so uh, we we were talk about the photosensitization reaction. Okay, so as we know that some molecules they are not undergoing with the reaction because of less activation is there, but it cannot be absorb light and get activated selfly and goes to the undergoes to be the reaction and produce the product. Not happen from the in case of the some reactant. So in that case, there you can add some additional substance that can be able to absorb the energy in the form of photon, in the form of light, and then undergoes to be the excitation. So it is called as the sensitizer. Okay. So these activated molecules and some atoms can be also used for the activation. So this activated molecule is also known as to be the photosensitizer. Okay, there are some atoms like mercury, cadmium, zinc. They can act as a sensitizer, so it is called as to be the atomic sensitizer. And some molecule also play the role as a sensitizer, so it is known as to be the molecular sensitizer. And their example is benzophenone and SO2. Okay, uramyl sulfate. It can be also act as a sensitizer. So these are the different sensitizer is there. So what happened in this photosensitization reaction? Firstly, photosensitizer is a donor. Photosensitizer is a donor. Why it is called as a donor? याला आपण डोनर का म्हणतो फोटोसेन्सिटायझरला? Because it absorb energy and undergoes to the excitation. Okay, from ground state energy level to the number of excited energy level that depend upon the absorption energy, intensity of absorption energy. Then in excited energy level, it lose the energy, like you can see here in pinkish form is here, lose the energy and convert into the triplet energy level, and from that it lose their energy, it transfer their energy, it donate their energy to the acceptor molecule or reactant molecule, you can see here. Okay, म्हणजे काय फोटोसेन्सिटायझरला डोनर का म्हणतो आपण? कारण हा स्वतःची ऍक्टिव्हेशन साठी वापरलेली जी काही एनर्जी आहे ती एनर्जी तो काय करतो या ऍक्सेप्टरला देतो. हे बघा इथे ऍक्सेप्टरला देतो अँड दॅट्स व्हाय इट इज कॉल्ड ॲज टू बी द डोनर. ओके, दिस इज कॉल्ड ॲज टू बी द डोनर. म्हणून आपण काय म्हणतो याला डोनर म्हणतो. ओके, so what happened, it get to be excited due to absorption of energy from a singlet energy level to the S1, S2. So these are the different excitation energy level. That energy level depend upon the how much energy absorbed by the donor. किती एनर्जी absorb करतो याच्यावरनं त्याचं किती एक्साइटेशन होईल हे डिपेंड असतं. म्हणजे किती लेवलवर जाईल, 1 वर, 2 वर, 3 वर. So that depend on the absorption of light by the donor or sensitizer. So sensitizer absorb energy and transfer from ground state energy level to excited energy level, and from this excited energy level it change into the triplet excited state energy level. Singlet and triplet, these are the related to the spin multiplicity. There's a singlet excited state and triplet excited state. So these are bluish color of this, all the energy changing is there. It is about the sensitizer or photo actinometer, or also called as to be the donor. ओके, हे सगळं हे ब्लूइश जे दिसतंय ना चेंजिंग, हे सगळं चेंजिंग कोणाचं आहे? या डोनरचं. सो फ्रॉम सिंगलेट एक्साइटेड स्टेट it convert into the triplet excited state through the ISC intersystem crossing. Okay, so due to that it convert into the triplet. So triplet is also the excited energy level. So in a triplet it gives their energy to the triplet energy level of the acceptor molecule. Okay, and then this acceptor molecule, after the accepting the energy, it undergoes to the again excitation and de-excitation, and it produces to be product. Okay, but in this whole process, this sensitizer, it donate their energy. Now you can see here, it donate their energy to the triplet state of the acceptor or reactant molecule. So that's why it is called as to be the donor, and it accepts the energy from my sensitizer. So it is called as to be the acceptor. So what happened? We see here his donor, it is represented by D in a ground state. It absorbs some photon energy and then it transferred to the singlet excited state. That is to be the S1, S2, S3. This is to be the singlet excited state. So in a singlet excited state, due to the intersystem crossing, there is a spin of this donating species is changed, and it convert their spin multiplicity into the triplet. So it is called as to be the triplet donating sensitizer. Okay, or simply called as a triplet excited state. So it is represented by T and this is represented by S. And then in a triplet energy level, this triplet energy level donor, it transfer their energy to the A. A is the acceptor or reactant molecule. Then it goes to their triplet energy level of acceptor molecule, and this D is the donor, it come to the ground state. Okay, now you can see here, this is to be the ground state condition, and this is again to be the ground state condition after giving the energy to the acceptor molecule or reactant molecule. Then this reactant molecule in a triplet energy level, it produces the product. So this process is known as to be the photosensitization. Okay. And if in this process, if this excited molecule, donor excited molecule, this is, you can see here, D3 is a donor excited molecule. If it is undergoes to be the reaction and produce the product. Okay. So this A is a become to be the quenching. ये जो आहे ना, तो इथे पार्टिसिपेट होणार नाही, तो अदृश्य राहील, त्याला क्वंचिंग असं म्हणतो आपण. किंवा इफ जो एक्साइटेड झालेला जो काही ऍक्टिनोमीटर आहे, जो सेन्सिटायझर आहे, इट शोज द प्रोडक्ट, इट कन्वर्ट इनटू द प्रोडक्ट. Okay, means before the reacting with the, before the transferring their energy to this active acceptor molecule, it convert into the product. So in that case, you can say it is a quenching condition. समजत आहे रे? Hello, I'm audible? Hello?
Yes, sir.
Okay, okay. समजत आहे ना? डायग्रामॅटिकली क्लिअर झालंय सगळं? हा महत्वाचा कन्सेप्ट आहे. Okay. So next point is here, we are going to be discuss about some example regarding to the photosensitization reaction. Okay, so there are some reaction is given, photosynthesis of carbohydrate, means photosynthesis there, dissociation of hydrogen molecule, dissociation of ethylene molecule, diazomethane and oxalic acid, means various decomposition of the molecule, and photosynthesis we are going to be discuss one by one. Okay, so next. So you can see here the reaction of photosynthesis, very famous reaction. In this reaction is occur in the presence of light. So first upon, what happened? Basically, you have to know that this reaction is occurring between two CO2 and H2 molecule. Okay, and in this synthesis reaction, there is a chlorophyll is work as a sensitizer. Okay, now the CO2 and H2O does not absorb energy. It does not absorb energy directly from the light. But what happened? Firstly, this chlorophyll, you can see here, this chlorophyll, okay, it is visible for you. Slide is visible for you.
Yes, sir.
So this chlorophyll absorbs this energy, photon energy, and then it turned into the activation condition. This is called as the, there you can see there is a star on this chlorophyll, so it is to be the activated molecule. Okay, it is the excited molecule. Okay, and then it is also called as the donor molecule. So in that state it gives their energy. Now you can see here that chlorophyll, they transfer their energy to the another reactant molecule like in a CO2 and H2, and then it produces the product as a carbohydrate. C CH2 6. It is the sixth molecule is there. So it is a C6H12O6, that is to be the glucose molecule is here. Okay. And O2 and chlorophyll again come to the ground state after loss their energy. So this is the example of photosensitization. Another example is the dissociation of H2. H2 molecule is dissociated in the presence of light, but there H2 does not directly absorb energy from the light. So that's why they use the mercury metal, it can be used here. So if mercury firstly absorbs this energy and undergoes to the excitation. So it is called as to be the donor or sensitizer. Okay. And then this sensitizer gives their energy to the hydrogen molecule, and then hydrogen molecule again get to be excited. Okay. Hydrogen molecule undergoes to the excitation. And in the excitation and energy level, it is break down into the two different or two hydrogen atom. And hydrogen molecule is decomposed as a twice H. Okay, so this is the decomposition of H2 molecule in presence of mercury as a photosensitizer. So it is the example of photosensitization reaction. Next example is the dissociation of ethane molecule. Okay, ethane molecule is dissociate and it convert into the uh, acetylene. Convert into the acetylene molecule. Means C triple bond C. This is called as to be the acetylene. Okay, so this alkane ethane molecule converted into the acetylene. So this is simply called as to be the decomposition of ethane molecule. But ethane cannot directly absorb energy. That's why they use the mercury for the sensitizer or donor. It absorbs energy and it undergoes to the excitation, and in triplet energy level it transfer their energy to the ethane molecule, and then ethane molecule get excited. Okay, and in a triplet energy level this ethane molecule is break down as acetylene plus H2. Okay, in this way you can understand the various example. The next example is the decomposition of diazomethane. Okay, so there is a benzophenone. It is used as a photosensitizer. This is the BZ is a benzophenone. It absorbs the energy and undergoes to the excitation, and then in excitation it acts as a donor. It donates their energy to the diazomethane, and then diazomethane get to be excited. Okay, and then diazomethane in a triplet energy level is decomposed into CH2 and N2 molecule. Okay, then another example is the decomposition of oxalic acid. We already discussed about it. Okay, in presence of uramyl sulfate, uramyl sulfate acts as the activated for activated molecule or donor molecule or photosensitizer is there, and then it absorbs energy and transfer their energy to the oxalic acid. In a triplet energy level, this oxalic acid excited and then it decomposes into the CO, CO2 and H2O. Okay, and last one is there, example is there, butene. See, butene molecule again break down in the presence of this sulfur dioxide as a photosensitizer, and it break down into the different product. Okay, so we can be understand these all examples are related to the photosensitizer, and that concept is very simple concept is there. Firstly, हा काय होतं की एक मॉलिक्यूल किंवा दोन मॉलिक्यूल जेव्हा रिएक्शन मध्ये जातात, पण ते डिरेक्टली जर एनर्जी ऍब्सॉर्ब फोटॉन एनर्जी ऍब्सॉर्ब होत नसेल आणि त्यांची रिएक्शन होऊन प्रॉडक्ट जर फॉर्म होत नसेल, तर अशा केसमध्ये आपण फोटोसेन्सिटायझर यूज करतो, आणि तो फोटोसेन्सिटायझर काय करतो, तो एनर्जी ऍब्सॉर्ब करतो, ऍक्टिव्हेटेड होतो. ऍक्टिव्हेटेड झाल्यानंतर सिंगलेट एनर्जी पासून तो ट्रिपलेट एनर्जी मध्ये जातो आणि ट्रिपलेट एनर्जी लेवल मध्ये गेल्यानंतर त्याची एनर्जी जी आहे ती एनर्जी तो ट्रान्सफर करतो कुणाला, त्या रिॲक्टिंग मॉलिक्युलला, एक्सेप्टर मॉलिक्युलला, आणि मग एक्सेप्टर मॉलिक्युल ऍक्टिव्हेट होतात आणि ते ट्रिपलेट स्टेट मध्ये जातात आणि मग ट्रिपलेट स्टेट मधनं ते प्रोडक्ट मध्ये कन्वर्ट होतात. ओके. आणि जो ऍक्टिव्हेट झालेला डोनर मॉलिक्यूल जो होता, जो फोटोसेन्सिटायझर जो होता, त्याने एनर्जी डोनेट केल्यानंतर इट कम टू द ग्राउंड स्टेट. ओके. So this is a very simple concept about the photosensitization. Okay, so we now come to this point is the kinetics of photochemical decomposition of HI. Okay, let's we going to be understand the kinetic. Okay, means rate of this reaction. Rate of this reaction we are going to be understand, and by considering the example as a decomposition of HI. But one thing you have to be understand here in case of the photosensitization reactions is that photosensitizer firstly absorb energy and then it convert their energy to the reacting molecule, and then reacting molecule further goes to be the reaction. Okay, so if you observe space minutely to this reaction, so you can be understand here this all the photosensitizer reaction is depend upon the absorption intensity by the uh, photosensitizer. Okay, absorption energy by the photosensitizer or intensity of light absorbed by the photosensitizer. Okay, means why? Because the energy is absorbed by any photosensitizer, so it undergoes to be the excitation. Okay, but on which energy level means singlet excitation state means there is number of excitation energy level, S1, S2, S3, S4 and so on, means that depend, this energy excited energy level is depend upon how much intensity of light absorbed by photosensitizer. त्या फोटोसेन्सिटायझरने किती एनर्जी अब्सॉर्ब केली यावरनं तो कुठल्या एक्साइटेशन एनर्जी मध्ये जाईल, that to be depend. Okay, and hence this first step, excitation of photosensitizer, this step is very much important in a photosensitization reaction. Okay, so let me begin to understand how the kinetics of photosensitization reaction, okay, is occur. So let me see here. There is a decomposition of HI is not happen in one step. Okay, so there are a different step. So first step is the primary process is there. So as we know that Bendenson explained these two process, primary and secondary processes. Okay, so according to that, the primary process is simply known as to be the activation process, okay, or excitation process. Okay, excitation of photosensitizer, okay, or actinometer also called as. So this first step is a primary process, and then second one is a secondary process, and then the product formation process or and reaction termination process. So this is to be the secondary process. Okay, so activated molecule then react with the secondary process. So let me see here what happened in a first step. There is a this HI is decomposed. I mean, HI is not completely decomposed in one step. Okay, it is in different steps. So in first step, what happened? This H nu is the energy is there, and the rate of this first step is the K1. K1 is the rate of reaction. HI is the molecule. This molecule absorb energy, and their breakdown is occur, that is to be the H and I. Okay, H and I. These are not a neutral molecule. There is not form the H2 molecule and I2 molecule. Okay, so there is H and I. Okay, so this molecule, this atom is there. So this is to be the excited atom is there. So this excited atom, this H, it react with, okay, this react with the another HI molecule. Okay, so this is the second process is there, second step is there. So HI combined with this H. Okay, so H and this H1, so there is a formation of H2 and their I is come out here. Okay, so let me see here. For this reaction, first reaction, HI absorb energy and break down as a H and I as a primary process. These two are the activated molecules here. And what happens? The rate is there is first rate for this reaction K1, and this totally the rate of this reaction is depend upon the H nu. H nu means intensity of absorbed by the this HI molecule. So there is a K1 A for absorption, I for intensity. Okay, so the rate for this reaction is a K1 is the dissociation constant and equilibrium constant also, and then K1 and then IE. Okay, in second step, this activated molecule, this highly reacting molecule is the atom is there, hydrogen, and then it react with the HI and form the H2. It form the H2. So this is to be the second step. So the rate of this reaction, that rate is equal to this K is the dissociation constant or equilibrium constant K. Okay, or simply rate constant you can say it. So that's K2. It depend upon the concentration of this H and concentration of HI. So let me see here. This is to be the rate for this reaction. Okay, and this third step is there. This not muchly interfering in the rate of this reaction because you can understand here the I form here and I form here. These two are combined and form the I2 molecule. There is the I2 molecule is formed. This is to be the third step, but that's K3, and this step is very fast, very fast because two one excited molecule and another is a excited molecule is there. Sorry, atom is there, and they combine and form the I2 molecule. So it is very fast reaction. Okay, so they is not considered in the determination of kinetics of the HR decomposition reaction. So these two steps are very much important, and then to find out this totally kinetic for the decomposition of that, so you consider this reaction, this complete reaction is a twice SI, दोन HI, it gives H2 plus I2. This is to be the complete reaction or net reaction है ना, या दोन्हीला combine केला आपण इकडे twice HI, H2 and I2. It gives H2 and I2. In this way, it can be decomposed. So for this decomposition of HI, the rate is here. Rate for this, it is the summation of these two. या दोघांचं आपण sum केलाय. So K1 means it is the rate of first reaction and the rate of second reaction. So you sum these two and you get this equation is here like this. Okay, but hydrogen atom are shorter lived applying steady state treatment. Okay, their hydrogen it form for very short time. Okay, because not hydrogen is not very stable atom. Hydrogen is not a stable atom because it is the only one electron activated species in this reaction. So it try to combine with the another hydrogen and form H2 molecule. Okay, so that's why their life is very short. So this equation is write down like this one. Okay, हे या इक्वेशन ला आपण हे असं लिहिलं. इथे हा जो रेट आहे this K1 rate is equal to be the rate of second reaction and rate of first reaction are same. Okay, इक्विव्हॅलंट रेट दाखवलेला आहे. इथे जर बघितलं तर आपण आता इथे H ला बाजूला काढू शकतो. कॉन्सन्ट्रेशन ऑफ H इज इक्वल टू काय करू आपण, हा जो K2 आहे आणि HI आहे तो याला इकडे डिवाइडेड करून देऊ. मीन्स यू गेट दिस इक्वेशन इज हियर. Concentration of H is equal to K1 IA upon K2 HI. Okay, and then put this value in equation, this equation. Okay, इथे value आपण आता put up करून देऊ. ठीक आहे, put the value of concentration of H. So if you put this value in this equation, then you can get such type of equation like here K1 Okay, there is a Ia, okay, plus what? K2H and HI. Means there is a K2 K2 concentration of HI, okay, and the value of H is this one, K1 and Ia, okay, upon what is this? K2 concentration of HI, concentration of HI. ठीक है, समझ आ रहे? Okay, so you can see here K2HI and this K2HI is cancelled. Okay, so what we get? This rate is equal to K1IA, and this K1IA means twice K1IA. So you can see here rate for this reaction that is equal to be twice K1IA. Means this K is a dissociation constant, equilibrium constant is there, but their total rate of this reaction is depend upon the IA, means intensity of absorbed light. ओके, म्हणजे आपण इथे काय म्हणू शकतो की हा जो काही रेट आहे या रिएक्शनचा, या रिएक्शनची जी कायनेटिक्स आहे, ती कायनेटिक काय रिप्रेझेंट करत आहे की टोटल रेट जो आहे या रिएक्शनचा, म्हणजे जे काही डिकम्पोजिशन होणार आहे या एच आयचं, एच आय डिकम्पोज इनटू दी H2 and I2 molecule after the absorption of light. So the rate of this reaction is depend upon the intensity of absorbed light by the first step. समजत आहे का? या पहिल्या स्टेप मध्ये किती इंटेन्सिटी ऑफ लाईट ऍब्सॉर्ब होतो तो डिसाइड करेल की डिकम्पोजिशन किती व्हायला पाहिजे. ओके, so this is to be the kinetics of photochemical decomposition of HI. You got this point? समजत आहे का रे पोरांनो?
Yes, sir. Yes, sir.
This is very simple, and one 4 marks question will be asked on this topic. You have to describe the photochemical decomposition of HI and describe their kinetics. Okay, so very simply, first the decomposition occur in a 2-step basically, and third step is very fast, so it cannot be considered. So their first step, and this is to be the second step, and rate for this first step and rate for the second step. So the summation of this, and then find out the value of H, concentration of H, then put this value of concentration of H in this equation, in summation equation, and then you can be cancel this same quantity and you will get the final equation is here. Rate is equal to be twice K1 I. I is the intensity and this is to be the constant value. So you can easily can be understand this rate is totally depend upon the intensity of absorbed light. Then, so we are talking about, we are most of the time we are using this term as excitation, transition, okay, so absorption of light. So next is qualitative description of fluorescence, phosphorescence and non-radioactive processes. Okay, when there a transition is occur from ground state to excited state. These are the singlet excited state and triplet excited state transition is there. Transition is also called as the process, excitation process of electrons. So this excitation process, it is two types. It is classified in two types. Okay, one type is there is no radiation is come out. There is no emission of light. No non-radioactive emission is there. Non-radioactive is there. And second one is here. Then second is the radiative type of transition is there. Okay, so two classes there, non-radioactive and second is radioactive. Non-radioactive and radioactive. Okay. So let me see. Okay. तर पहा कसं होतं, आपण काही रिॲक्शन घेऊ आणि त्याच्यावरनं समजू. पहा non-radiative transition. Non-radiative means there is no emission of light. There is no emission of light. Means what happen? Electron काय करतो? In ground state, electron absorbs some energy and undergoes to be the excitation. It undergoes to be excitation. So this excitation of this electron, तुम्ही हॅलो हॅलो
हाँ सर
हा
बोला.
आवाज येतोय ना?
हाँ सर.
ओके. तर पहा, electron in a ground state, it absorbs some energy, okay, and it undergoes to be excitation है ना. एक्साइटेशन होऊन जातं. आपण या डायग्राम मध्ये जॉबलमस्की मध्ये स्टडी करू. ओके, लेट इट सी. ग्राउंड स्टेट, इथे ग्राउंड स्टेट मध्ये काय करतो, एनर्जी ऍब्सॉर्ब केली येथे या S0 लेवल वरती आणि हा मूव्ह झाला S1 S2 एक्साइटेड एनर्जी वरती तो मूव्ह झाला. याला काय म्हणतो आपण, एक्साइटेशन ऑफ इलेक्ट्रॉन म्हणतो है ना. But excitation of electron, and in this excitation of electron what happened, from ground state to excited energy लेवल वरती हा येऊन जाईल. आणि या एक्साइटेड एनर्जी लेवल वरती गेल्यानंतर काय होतं की हा S2 पासनं मीन्स हायर एक्साइटेड एनर्जी लेवल टू लोअर एक्साइटेड एनर्जी लेवल वर हा इलेक्ट्रॉन येणार. ठीक आहे ना. व्हेन इट कम टू द ग्राउंड स्टेट है ना, आफ्टर द एक्साइटेशन it come to the ground state. So you can see here we are talking about the non-radiative transition. Non-radiative म्हणजे असं काही ट्रान्झिशन, असं काही इलेक्ट्रॉनचं एक्साइटेशन आणि डिएक्साइटेशन की ज्याच्यामध्ये इलेक्ट्रॉन लाईट एनर्जी इमिट करत नाही. नॉन रेडिएटिव्ह. ओके, लक्षात येतं ना मिनिंग. मग इथे काय होतं की हा एक्साइटेड एनर्जी लेवल पासनं कमी एनर्जीच्या एक्साइटेड एनर्जी लेवलवर जेव्हा इलेक्ट्रॉन येतो तेव्हा तो काय करतो, इथे त्याची इंटरनल कन्व्हर्जन तो करून घेतो फ्रॉम S2 टू S1. इंटरनल कन्व्हर्जन means it come from the higher excited energy level to lower excited energy level. Both are the excited energy level, but this is the higher excited energy level and this is to be the lower excited energy level. Okay, so this is to be the internal conversion. So the internal conversion is occur. So here you can आपण इथं म्हणू शकतो की हा हायर एनर्जी पासून लोअर एनर्जी मध्ये आला एक्साइटेड एनर्जी लेवल मध्ये, म्हणजे याने एनर्जी लॉस केली असेल, बरोबर आहे ना. बट देर इज नो लॉस ऑफ एनी एनर्जी, देर इज नो एनी एनर्जी light energy come out during this internal conversion. Okay, so that's why it is known as to be non-radiative transition or non-radiative process. Okay, so what happened? Why not emit their light energy here? Because some energy use, some absorption energy is used by this electron for the or dissipated in the form of heat. काय होते, थोडं हीटच्या फॉर्म मध्ये तो जो मॉलिक्यूल आहे, तो जो ऍटम आहे, ती एनर्जी यूज करतो. ओके, इन द फॉर्म ऑफ ती हीटच्या फॉर्म मध्ये कन्वर्ट होऊन जाते. दॅट्स व्हाय इट इज कॅन नॉट बी इमिट ऍज अ लाईट एनर्जी. आलं का लक्षात? म्हणजे ऍब्सॉर्प्शन एनर्जी केली, एक्साइटेड लेवलला गेला, S1 ला गेला, S2 ला गेला, पण हा जो S2 ला गेलेला होता तिथनं तो काय झाला, इकडे परत S1 ला परत आलेला आहे. बोथ आर द एक्साइटेड एनर्जी लेवल, बट देअर एनर्जी ऍब्सॉर्ब एनर्जी इज यूज in the form of heat, or it convert in the form of heat. So that's why it cannot be emit energy. So it is called as to be non-radiative process. Okay, and this process is known as to be internal conversion. Means if you move from higher excited energy level to the lower excited energy level, so this is called as to be internal conversion. It is called as to be internal conversion. ठीक आहे. अँड याच्यासाठी टाइम जो लागतो ना 10 to the power minus 14 to 10 to the power minus 11 सेकंद एवढा टाइम लागतो याला. ठीक आहे. हे कन्वर्जन इंटरनल कन्वर्जन म्हटलं. So this is to be the non-radiative process. Then second is here when the singlet excited energy level electron it convert into the triplet energy excited state level, means when इलेक्ट्रॉन म्हणजे इलेक्ट्रॉन जर हा सिंगलेट एक्साइटेड एनर्जी लेवल पासून जर ट्रिपलेट एक्साइटेड एनर्जी लेवल वरती जर गेला तर इथे सुद्धा तो कुठलीच लाईट एनर्जी इमिट करत नाही. बट व्हॉट हॅपन इन दिस प्रोसेस, देर इज अ इंटर सिस्टम क्रॉसिंग इज देअर. इंटर सिस्टम क्रॉसिंग तिथे होतं. म्हणजे हा जो काही इलेक्ट्रॉन आहे जर इथे याचा स्पिन हा जर अपवर्ड साइडला असेल तर तो इथे जो होतो ट्रिपलेट स्टेटला तो डाउनवर्ड साइडला. Means what happened, there is the inter-system crossing is occur. Inter-system crossing, but during that again this energy is repeated in the form of heat. It does not emit as a light energy. इथे कुठलीही लाईट एनर्जी तो बाहेर टाकत नाही, कुठलंही रेडिएशन तो बाहेर देत नाही. That's why it is called as the non-radiative processes. And this is called as to be intercrossing system or intercrossing system is there. And these both are the non-radiative condition. This is to be the non-radiative conditions. Okay. तर आपण इथे काय म्हणू शकतो की जे काही इंटर कन्वर्जन आहे अँड इंटर क्रॉसिंग इंटर सिस्टम क्रॉसिंग आहे, या दोन स्टेप मध्ये लाईट एनर्जी रिलीज होत नाही, इमिट होत नाही. तर काय होतं, जी ऍब्सॉर्ब केलेली एनर्जी आहे ती काय होते, हीट मध्ये डिपिटेड होऊन जाते, म्हणजे डिस्ट्रीब्यूट होऊन जाते, कन्वर्ट होऊन जाते बाय दिस ॲटम ऑन मॉलिक्यूल. अँड इट इज कॉल्ड ॲज टू बी द नॉन रेडिएटिव्ह प्रोसेस. ओके. Then second is a radiative process. ओके. हे इथं सांगू शकतो आपण इंटरनल कन्वर्जन. लक्षात आलं इंटरनल कन्वर्जन कशाला म्हणायचं. ओके. हॅलो.
Yes, sir.
सेकंड वन इज इंटर सिस्टम क्रॉसिंग. लक्षात आलं. या दोन्ही टर्म लक्षात आल्या काय आहेत. पहा, इंटर कन्वर्जन म्हणजे काय होतं की S2 S3 टू S2 मुवमेंट है ना, किंवा T3 टू T2 मुवमेंट, किंवा S2 टू S1 मुवमेंट, किंवा T2 टू T1 मुवमेंट. हे जे काही मुवमेंट होते एक्साइटेशन एनर्जी लेवल वरती, फ्रॉम हायर एक्साइटेशन एनर्जी लेवल, हायर एक्साइटेशन एनर्जी आणि त्याच्यानंतर लोअर एक्साइटेशन एनर्जी लेवल है ना, असं म्हणू शकतो आपण. म्हणजे इथे जर S3 असेल तर ही कुठली झाली, S2 झाली. इथे जर T3 असेल तर ही कुठली झाली, T2 झाली है ना. किंवा इथे जर समजा T2 असेल तर ही झाली T1. इथे जर समजा S2 असेल तर ही काय झाली, S1. लक्षात येत आहे का. Means if you move from this higher energy level to this lower excited energy level, so it is called as to be internal crossing. Okay. And if you move from singlet, आता इकडे पहा, हे बघा S1 टू T1 है ना, इथं थोडं क्रॉस होत आहे. म्हणजे S1 चं कन्वर्जन T1 मध्ये है ना, S2 चं कन्वर्जन T2 मध्ये है ना, किंवा S3 चं कन्वर्जन T3 मध्ये. बरोबर आहे ना. असं जर कन्वर्जन, आता इथे S चं कन्वर्जन S मध्ये, T चं कन्वर्जन T मध्ये, म्हणून याला इंटर कन्वर्जन म्हटलं. आणि इथे काय होत आहे S2 to T2 म्हणजे काय वेगवेगळे आहे क्रॉसिंग आहे. सो दिस इज टू बी द इंटर सिस्टम क्रॉसिंग. ओके. आणखी एक गोष्ट लक्षात ठेवा इंटर कन्व्हर्जन मध्ये त्याचं जे स्पिन आहे म्हणजे सिंगलेट S3 लेवलला हा S3 एनर्जी लेवल आहे तिथे त्याचं स्पिन अपवर्ड आहे. बट इफ इट मूव टू S2 एनर्जी लेवल सो देअर स्पिन इज ऑल्सो सेम. त्याचं स्पिन जसंच्या तसंच राहतं. त्याचं स्पिन काय होत नाही चेंज होत नाही. ओके. सो दिस इज कॉल्ड ॲज टू बी द स्पिन अलाउड ट्रान्झिशन. त्याला काय म्हटलं जातं स्पिन अलाउड ट्रान्झिशन. ठीक आहे. आता दुसरी कंडिशन अशी आहे की जेव्हा S1 टू S2 टू T2 जातो तो है ना इंटर सिस्टम क्रॉसिंग जेव्हा होते तेव्हा जर S2 मध्ये त्याचं स्पिन हे अपवर्ड साइडला जर असेल तर तो T2 मध्ये जेव्हा जातो तेव्हा त्याचं जे स्पिन आहे इलेक्ट्रॉनचा तो काय होतो असं अपोजिट होते. समजत आहे हा कन्सेप्ट समजून घ्या. ओके. पहा काय कसं कन्वर्जन होते काय कन्वर्जन होतं हे लक्षात आलं पाहिजे. ठीक आहे. सो इन दिस वे यू कॅन बी अंडरस्टँड टू द नॉन रेडिओएटिव्ह प्रोसेस. No radiative process means there is no emission of energy, just convert this absorption energy into the heat. Okay. Next one is here radiative process. Radiative process means there is a loss of energy in the form of light, in the form of fluorescence, in the form of phosphorescence. Okay. So what these terms let's we understand. Let me see here. When काय होतं this ground state electron it move from ground state energy level to excited energy level. ओके. लक्षात घ्या ग्राउंड स्टेट पासून तो कुठे गेला एक्साइटेड एनर्जी लेवलला गेला आणि एक्साइटेड एनर्जी लेवल वरनं इट लॉस एनर्जी अँड इट कम टू द ग्राउंड स्टेट. म्हणजे इकडे लक्षात घ्या this is green arrow. You can understand by this green arrow. Green arrow for the absorption of light. It absorbs and it undergoes to the excitation from S0 to S1 and S2. Okay. But after some time, it lose their energy in the form of light and absorption energy is released in the form of light and come to the ground state. So you can see here, there is a red light is here. Red line you can understand. There is a this excited molecule come to the ground state. Okay. So this molecule S1 to S0. Okay, it come to the S1 to S0 means this is to be the de-excitation of electron. But during this de-excitation of electron, it release some energy. It release energy. So this release energy in the form of light, and that light is known as to be, that radiation is known as to be the fluorescence. इथे जो काही लाईट बाहेर निघतो त्याला काय म्हटलं जातं फ्लोरोसन्स. यू कॅन अंडरस्टँड दिस इज द ओके फ्लोरोसन्स. ओके. This fluorescence come from excited to the ground state. It require time is a 10 to the power minus 9 to 10 to the power minus 7 seconds. Okay, means very fastly it come to the excited energy level to the ground state energy level. लक्ष देत आहे म्हणजे तो पहा ग्राउंड स्टेट पासन इट मूव टू द एक्साइटेड एनर्जी लेवल and in excited energy level is lose the energy in the form of light and come to the ground state. So this releasing energy during this de-excitation of electron from S1 to S0, this is called as to be the fluorescence. Okay. And this fluorescence time it is 10 to the power minus 9 to 10 to the power minus 7 second. It's very fastly it comes to the ground state and give this energy. Okay. Next one is here means due to the inter-system crossing, the singlet excited state energy level electron move to the triplet energy level, excited energy level. Okay. So their spin is changed. Okay. And energy of triplet excited state energy level is their energy is less or small as compared to be the singlet excited energy level. या सिंगलेट एक्साइटेड एनर्जी लेवल पेक्षा ट्रिपलेट एनर्जी लेवल जी आहे ती कशी आहे, कमी आहे. ठीक आहे. And when this electron it come from triplet excited energy level to ground state energy level, so it lost the radiation in the form of light is known as to be phosphorescence. It is known as to be phosphorescence. Okay, and it takes somewhat larger time than fluorescence. Okay, there are two terms there, fluorescence and phosphorescence. Okay, this phosphorescence in the triplet excited state electron come to the ground state by the loss of energy in the form of fluorescence, and it take 10 to the power minus 13 to minus 12 seconds, so it somewhat slowly come to the ground state as compared to the fluorescence. Okay, second thing, the energy come out or fluorescence energy or intensity of the fluorescence is less. It is less as compared to the intensity of absorption light by the electron. म्हणजे काय की जेव्हा हा इलेक्ट्रॉन या ट्रिपलेट एक्साइटेड एनर्जी लेवल पासून ग्राउंड स्टेट एनर्जीला येतो, तेव्हा तो फ्लोरोसन्स एनर्जी जो आहे इन द फॉर्म ऑफ लाईट तो बाहेर देतो फ्लोरोसनच्या फॉर्म मध्ये. तर या फ्लोरोसनची जी इंटेन्सिटी असेल ती इंटेन्सिटी या इथे जी एनर्जी ऍब्सॉर्ब होत आहे ना, आहे इंटेन्सिटी ऑफ ऍब्सॉर्प्शन लाईट जी आहे याच्यापेक्षा याची इंटेन्सिटी जी आहे, इंटेन्सिटी ऑफ फ्लोरोसन्स म्हणू आपण, फॉस्फोरसन्स म्हणू, ही कशी राहते, कमी राहते. इंटेन्सिटी ऍब्सॉर्प्शन इंटेन्सिटी इट इज ग्रेटर दॅन फॉस्फोरेसन्स इंटेन्सिटी. और लक्षात येत आहे का हे कन्सेप्ट? इंटेन्सिटी हा का बरं होत असेल असं, इंटेन्सिटी ऍब्सॉर्प्शन लाईटची जी आहे इथे ती जास्त आहे आणि फ्लोरेसन्सची इंटेन्सिटी कमी आहे, असं का बरं? सांगता येईल? हॅलो 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 हॅलो, अरे आवाज येतो की नाही रे?
यस सर, येत आहे आवाज.
हा हा, कोणाला सांगता येईल का? पहा, इंटेन्सिटी ऍब्सॉर्प्शन आहे, इथं ऍब्सॉर्प्शन होत आहे, इलेक्ट्रॉन ऍब्सॉर्ब करतो एवढी इंटेन्सिटी, मग तो एक्साइटेड झाला S1 S2 लेवल वरती, मग S1 वरनं आणि S2 वरनं जेव्हा तो S1 मध्ये येतो म्हणजे इंटर कन्व्हर्जन होतं, त्यानंतर इंटर सिस्टम क्रॉसिंग होते. या सिस्टम मध्ये काय होते की काही एनर्जी जी आहे ती हीटच्या फॉर्म मध्ये डिपिक्टेड झालेली आहे ना, कन्वर्ट झालेली आहे. म्हणजे जी इथे जर समजा 10 जूल एनर्जी ऍब्सॉर्ब झाली असेल तर इथे काय जवळपास 1-2 ऍटलिस्ट 2 जूल एनर्जी काय झाली, युटिलाइज झालेली आहे. ठीक आहे, 2 फोटॉन म्हणजे 10 फोटॉन म्हणू आपण, इथे 10 फोटॉन एवढी इंटेन्सिटी इथे ऍब्सॉर्ब झाली, इथे 2 फोटॉन एवढी एनर्जी यानी इथे यूज केली हीट मध्ये कन्वर्ट करायला. तर इकडे येताना तो किती आला, इथे आता 8 फोटॉनच झालेला आहे, बरोबर आहे ना. आणि मग तो 8 फोटॉन हा एक्साइटेड पासून ग्राउंड लेवलवर येणार, तर इथे काय करेल, तो 8 फोटॉन एवढी एनर्जी रिलीज करेल. समजत आहे का आता? इथे 10 फोटॉन एनर्जी आणि इथे 8 फोटॉन एनर्जी, म्हणजे काय झालं, 10 इज ग्रेटर दॅन 8. ओके, so due to this intercrossing and intersystem crossing, internal conversion, so this energy is decreased or utilized for the conversion or heating of the molecule, and then remaining energy is attained at the triplet excited energy level and it come to the ground state energy level. So the intensity of this phosphorescence म्हणजे हा जो फॉस्फोरेसन्स आहे इथे जो येतो तो, त्या फॉस्फोरेसन्सची एनर्जी इंटेन्सिटी जी आहे ती काय होते, कमी होते as compared to the intensity of absorption of light. Is that clear? Okay. So now this is to be the radioactive processes. There are two concepts is there, fluorescence and phosphorescence. Now you can see here spin multiplicity. आता तो कन्सेप्ट होता फ्लोरोसन्स आणि फॉस्फरसन्स. फ्लोरोसन्स अँड फॉस्फरसन्सला एक्सप्लेन करण्यासाठी जॉबलॉन्स्की डायग्राम वापरल्या जाते. ओके, सो जॉबलॉन्स्की डायग्राम इट इज एक्सप्लेन इन बाय यूजिंग द टू टर्म्स. फर्स्ट वन इज द स्पिन मल्टिप्लिसिटी and then second fluorescence and phosphorescence. Okay, so first of all we have to understand what is meant by the singlet excited state, what is meant by the triplet excited state, what is meant by ground singlet ground state. Okay, so here terms upon some review. So this all it can be understand from the spin multiplicity. Spin multiplicity means what? There is a 2s plus 1. 2s plus 1 is a spin multiplicity. Okay, so 2s plus 1. So s is the spin quantum number. Spin quantum number of all electron. Okay, we know that the half plus half is a or plus half or minus half is a spin of single electron. Okay, so if there is a number of electron in the atom or molecule, so sum of that all electrons, so it is due to the spin, total spin for this atom or molecule. Okay, so if you consider this condition, this two electron in one energy level, pairing of electron is there, so you can see here plus half spin for this electron and minus half spin for this electron. Okay, so total spin for this pair is a s is equal to be 0. S is equal to be 0. Okay, then put the value s is equal to 0 in a spin multiplicity. Okay, so this is to be the 2 into 0. Okay, plus 1 plus 1 काय होईल? That is equal to be 1 है ना. 2 into 0 is a 0 plus 1 is a 1. So spin multiplicity is a 1. Okay, so this is called as to be the singlet spin multiplicity, and this is at ground state, so it is called as the singlet ground state condition. It is called as to be the singlet ground state level or singlet ground state multiplicity असंही म्हणू शकतो. Okay, so this is simply called as a singlet ground state. Okay, then in a ground state, one of the electron from this pair it absorb energy. हा काय करतो इथे एनर्जी ऍब्सॉर्ब करतो आणि एका इलेक्ट्रॉनचं काय होतं इथे एक्साइटेशन होऊन जातं. देन यू कॅन सी दिस सेकंड कंडिशन बी ही. ओके, इथे काय झालं, एका इलेक्ट्रॉननी या इलेक्ट्रॉन एनर्जी ऍब्सॉर्ब केली आणि इट मूव टू द हायर एनर्जी लेवल. इट इज मूव टू दी हायर एनर्जी लेवल. मग इथे हायर एनर्जी लेवलला गेला तो. ओके, now you can see here there is a spin for this is a plus is a minus half, sorry, this is to be the minus half and this is to be the plus half. Okay, एक s जो आहे तो प्लस हाफ आहे, दुसरा s आहे, याला s1 म्हणू आपण, स्मॉल s1, याला स्मॉल s2 म्हणू. या दोघांचा जर सम केला तर काय होईल, s1 plus s2 काय होईल, is s is equal to be 0. Okay, then put this value in a spin multiplicity equation, म्हणजे हे 2s plus 1, again it is equal to be the 1. Okay, so it is called as to be the singlet. Again it is the singlet excited state. लक्षात येत आहे का, ही टर्म असते ती singlet excited state. So this is the condition for the singlet excited state. Okay, s is equal to 0, then spin multiplicity is 1. So this is the condition for the singlet excited state. Okay, so there is the intersystem crossing is occur, and during this intersystem crossing this electron convert into this स्पिन. ओके, आता हा खाली होता इलेक्ट्रॉन है ना, इकडे असा खाली येत होता याचा स्पिन, म्हणजे मायनस हाफ होता. आता काय झालं, इथं इंटर सिस्टम क्रॉसिंग झालं आणि इंटर सिस्टम क्रॉसिंग मध्ये ISC मध्ये काय झालं, इथं स्पिन चेंज झाला. आता स्पिन चेंज झाल्यामुळे काय होतं पहा, दिस इज द फॉर दिस इलेक्ट्रॉन देर इज अ प्लस हाफ, फॉर दिस इलेक्ट्रॉन this is again plus half. So total spin for this is a S is equal to be किती राहील 1.
1.
S is equal to 1. आता S is equal to 1 असेल तर ते या फॉर्म्युल्यामध्ये ठेवा. 2 into 1 that is 2 plus 1 that is equal to be 3 है ना, 3. So it is this condition for the triplet excited state. कशासाठी आहे, ट्रिपलेट एक्साइटेड स्टेट. म्हणजे असं हे ग्राउंड स्टेट पासनं एनर्जी ऍब्सॉर्ब करतो, मग तो एक्साइटेड एनर्जीला जातो आणि एक्साइटेड पासनं तो ट्रिपलेट एनर्जी मध्ये ट्रिपलेट एक्साइटेड स्टेट मध्ये कन्वर्ट होतो. सो दिस ऑल अबाउट द स्पिन मल्टिप्लिसिटी. हे सगळं कसं आहे, स्पिन मल्टिप्लिसिटी आहे, सिंगलेट, ट्रिपलेट. ओके, सो यू कॅन अंडरस्टँड द चेंज during this spin multiplicity. Okay, another thing is there. For the ground state there is no number of ground state, only one ground state is there, that is S is equal to काय राहते, S is equal to 0. हे ग्राउंड स्टेट आहे, त्याला S is equal to आपण काय म्हणतो, 0 म्हणतो. ठीक आहे, but there's it absorb energy, one of the electron from that, and how much energy is absorbed, on the base of that it undergoes to the excitation energy level. So there is a number of energy, excited energy level. This is to be the S1. Okay, याला जर आपण S1 म्हटलं, सिंगलेट एक्साइटेड स्टेट म्हणू आपण फर्स्ट. त्यानंतर S2 म्हणू, अगेन इट इज टू बी द सिंगलेट एक्साइटेड स्टेट बट हायर एनर्जी. देन S3 म्हणू आपण याला. So this is to be the again singlet excited state, but their energy is higher. The energy goes on to be increases from S1, S2, this is to be the S2, this is the S3, and this is the S1. So you can see here this energy level is increases, S1, S2, S3. Okay, so this is all about, it means if it is absorbed, जर यानी 5 फोटॉन ऍब्सॉर्ब केले तर S1 ला जाईल, जर त्याने इथे 8 फोटॉन ऍब्सॉर्ब केले तर तो S2 ला जाईल, आणि जर त्याने तिथे 10 फोटॉन ऍब्सॉर्ब केले तर तो S3 ला जाईल. बरोबर आहे ना, म्हणून आपण काय म्हणणार की S1, S2 and S3 and so on, म्हणजे खूप साऱ्या असू शकतात. These are the singlet excited state. These are the singlet excited state. Number of Sn. Lastly there is Sn. Number of excited state is there. S1, S2, S3, S4 and so on. Similarly इकडे ट्रिपलेट मध्ये पण तसंच. मग इथं ही याला आपण T1 म्हणू. ओके, नंतर आहे ती T2 असेल, नंतर असेल ती T3 असेल, असं. ओके, असं आपण याला सांगू शकतो ट्रिपलेट एक्साइटेड एनर्जी लेवल. ठीक आहे, आणि या ट्रिपलेट एक्साइटेड एनर्जी लेवल मध्ये पुढे आपण काय सांगू शकतो की नंबर ऑफ एक्साइटेशन एनर्जी लेवल झाल्या. आता आणखी एक गोष्ट याच्यामध्ये आपल्याला सांगता येतं की जी एनर्जी आहे या सिंगलेट एक्साइटेड स्टेटची जी एनर्जी आहे ना, म्हणजे ही एनर्जी ऑफ सिंगलेट एक्साइटेड स्टेट जी एनर्जी आहे, मग S1 असो, S2 असो की S3 असो, ती कशी आहे, ग्रेटर आहे ऍज कम्पेअर टू द एनर्जी ऑफ ट्रिपलेट एक्साइटेड स्टेट. समजून घ्या, ES1 इज ग्रेटर दॅन ET1, तसंच ES2 इज ग्रेटर दॅन ET2, तसंच ES3 इज ग्रेटर दॅन ET3. समजत आहे, म्हणजे सिंगलेट एक्साइटेड स्टेट एनर्जी लेवल इज हायर ऍज कम्पेअर टू दी ट्रिपलेट एक्साइटेड एनर्जी लेवल. ओके, देन आणखी याच्यामध्ये सांगू शकतो आपण की if the electron move from S2 energy level to S1 energy level, इथनं इथे जेव्हा इलेक्ट्रॉन जम्प करतो तेव्हा त्याला म्हटलं जातं इंटर कन्वर्जन. ओके, and if the electron is moved from singlet excited energy level to triplet means S1 to T1 जेव्हा मूवमेंट होते तेव्हा त्याला काय म्हटलं जातं ISE इंटर सिस्टम क्रॉसिंग. ओके, हे सगळ्या गोष्टी ज्या आहेत दिस ऑल अबाउट दी स्पिन मल्टिप्लिसिटी. ओके, so after you understanding the spin multiplicity you can understand the fluorescence and phosphorescence. Okay, so what happened, this energy is absorbed at ground state, electron goes to the excited energy level, these are the number of excited energy level, and then it come from excited S2 to S1 by the intercrossing interconversion, and from S1 to ground state, and it lose the energy in the form of light, so it is called as to be the fluorescence. Okay, so due to the intersystem crossing, electron move from S1 to T1, so there is a spin change. Okay, and the energy of T1 is small as compared to energy of S1, and when electron move from T1 to ground state, so it emit the radiation in the form of phosphorescence. Okay, so this is all about to be the Joblonski diagram, fluorescence, phosphorescence, and spin multiplicity. Joblonski diagram, it is used to explain the fluorescence and phosphorescence with the help of spin multiplicity and excitation, de-excitation of electrons. Okay, you got this point? So you can understand here this a photosensitizer or donor atom D at this S0 energy level, it absorbs this energy, photon energy, light energy, and it move from S0 energy level to S1 and S2 and S3 and number of energy level. Okay, and due to the ISC, it move from, this is the D1, this is to be the D1 because it is to be the excited energy level. So it moved from D1 to D3 here. This is to be the D3 condition. So at the D3 level, it gives their energy to the acceptor molecule. इथून तो काय करतो, त्या acceptor molecule ला energy देतो and it come to the, हा काय करतो, acceptor molecule ला energy देतो म्हणजे कोणती energy देतो, ही energy देतो. तो नॉन इथून सॉरी ही फॉस्फोरसन्स जी एनर्जी इथनं रिलीज होते ती एनर्जी कोणाला दिली जाते, एक्सेप्टर मॉलिक्यूल. आणि मग हा एक्सेप्टर मॉलिक्यूल काय करतो, ही एनर्जी घेऊन स्वतः एक्साइटेड होतो आणि मग तो फर्दर रिएक्शन शो करतो. ओके, so this is to be the Joblonski diagram. Then fluorescence you can see here. Okay, these are the very colorful emission come out from the any compound in from the chemical reaction. So these are to be the fluorescence. Okay, the light absorbed may be emit almost instantaneously in one or more step. This phenomenon is known as to be fluorescence. Okay, लाईट या लाईट काय होतं याच्यामधनं कम आउट होतं, इमिट होतं याच्यामधनं, त्याला म्हटलं जातं फ्लोरोसन्स. बट वेअर द लाईट absorb may be remit almost instantaneously in one or more step. Means how much light is absorbed, this light is emit. म्हणजे इंटेन्सिटी जेवढी absorb केली तेवढी इंटेन्सिटी तो काय करतो, बाहेर रिलीज करतो और नियरली अबाउट एनर्जी रिलीज करतो. दिस इज टू बी द दिस फेनॉमेना. या फेनॉमेनालाच काय म्हटलं जातं, फ्लोरोसन्स म्हटलं जातं. आता फ्लोरोसन्स आपण आता स्टडी केलं. इफ इट इज इलेक्ट्रॉन कम फ्रॉम S1 एनर्जी लेवल टू S0 एनर्जी लेवल, so it is called as it release energy in the form of light is known as the fluorescence. Okay, solution of quinine sulfate, visible light blue. Quinine sulfate solution, it emit the visible light, blue color light is emitted, so this is called as to be the fluorescence by the quinine sulfate. Then fluorescence like a chlorophyll shows blood red. Okay, chlorophyll shows blood red. So this blood red emission is a fluorescence. Means the excited chlorophyll from S1 energy level, it come to the S0 energy level. So emit radiation is known as to be the fluorescence. Is known as to be fluorescence. Then phosphorescence, you already understand. If the electron jump from T1 energy level to S0 energy level, so it gives energy. Okay, so this phosphorescence is a spin forbidden. There is a spin forbidden condition. This is to be the spin. Okay, and example is the sulfate of calcium and barium and strontium. So this is all about the fluorescence and phosphorescence. These are some examples. Okay. Okay. So let me see. The fluorescence and phosphorescence are different types there. So their name is given as per their reactions is there. In which reaction it come out. Okay. Whether it is chemical or whether it is biological. So on base of that it classified. So first is the chemiluminescence. Chemiluminescence means in a chemical reaction, the light is emitted. Light is emission come out during the chemical reaction is known as to be the chemiluminescence. ओके, एखादी केमिकल रिएक्शन केली आणि केमिकल रिएक्शन मध्ये लाईट हा इमिट होतो, त्याला म्हटलं जातं केमिकल. ओके, इट जस्ट द रिव्हर्स ऑफ फोटोकेमिकल रिएक्शन. ओके, photochemical reaction मध्ये what happen in a photochemical reaction? It absorb energy. It absorb energy. But in chemiluminescence, there is a release energy, emission of light. There is a emission of light in chemical reaction. म्हणजे chemical reaction होत असतं आणि त्याच्यामधनं light हा emission होतो असतो, बाहेर येत असतो in the form of light. So this is called as to be the chemiluminescence. And photochemical reaction मध्ये light absorb केला जातो. Okay. So oxidation of phosphorus. As you know that भूताचे टेमे माहिती आहे ना आपल्याला, जंगलमध्ये दिसतात, गावामध्ये कन्सेप्ट असतो. काय होतं की ज्या डेड बॉडीज असतात त्या अॅनिमल्सच्या असो किंवा कोणाची असो डेड बॉडीज, त्याच्यामध्ये काय असतं, सल्फर हा बाहेर निघत राहतो. जर डेड बॉडी ही मातीत गाडलेली असेल तर त्यामधनं फॉस्फरस बाहेर येतो. अँड इफ फॉस्फर इज कम इन कॉन्टॅक्ट विथ ऑक्सिजन, सो व्हॉट हॅपन, oxidation of phosphorus is occur, and during that fluorescence is come out. This chemiluminescence is come out. Okay, so their chemiluminescence is a greenish white luminescence is there. Okay, phosphorus oxidation झालं, P2O5. This is the oxidation of phosphorus, and this reaction gives greenish white color. Okay, then oxidation of luminol. Okay, I'm show some picture to you. Let me see here. In forensic lab है ना, आपण पाहतो डिटेक्टिव्ह वगैरे बऱ्याचशा आपण सिरियल पाहतो है ना, किंवा काही केसेस जर तुम्ही ऑब्झर्व केल्या तर इन दॅट यू कॅन अंडरस्टँड the some chemical compound. This chemical compound is a luminol. The name is luminol. It is used to detect, okay, in detection process. Okay, हा डिटेक्शन प्रोसेस मध्ये म्हणजे कोणाचा फिंगरप्रिंट्स आहे की हे ब्लड, इथे ब्लड पडलाय, ब्लड सॅम्पलिंगला अनालाइज करायचं असेल तर त्यासाठी लुमिनल हा कंपाऊंड वापरला जातो. हा लुमिनल कंपाऊंड, सो इट गिव्ह सच अ टाइप ऑफ केमिलुमिसन्स है ना, हे अशा टाइपचे केमिलुमिसन्स देतो. त्यावरनं आपल्याला त्या ठिकाणचे काही जे इम्प्रेशन्स असतात ते इम्प्रेशन आपल्याला आयडेंटिफाय करता येतात. ओके, विथ द हेल्प ऑफ दिस luminol this compound is there. Okay, हा फोरेन्सिस मध्ये लॅब मध्ये वापरला जातो. The second class is the bioluminescence. Bioluminescence means in biological process there is a emission of light is occur. Emission of light in biological process means if you see the fireflies, ओके, फायरफ्लाईज बघितल्या आहेत आपण, है ना? हे बघा फायरफ्लाईज आहे इथे, आपण पाहू शकतो फायरफ्लाईज, है ना? या फायरफ्लाईज पहा. Okay, it emits the light. Okay, but there is the light is come out it because of the chemical reaction. So the chemical reaction is a oxidation of luciferin protein. Luciferin is a protein in this fireflies. That luciferin is oxidized. This is the structure of luciferin, is oxidized in presence of ATP. Okay, it is oxidized in presence of ATP and magnesium. So this luciferin convert into the oxyluciferin, and in this oxyluciferin it gives light. It gives a light. Means this is the chemical reaction is occurring living organism. So in that living organism it gives the light. So this is called as to be the bioluminescence. याला काय म्हटलं जातं? Bioluminescence म्हटलं जातं. There are some fishes, they also give some bioluminescence. It also gives bioluminescence. Some algae, you can see here, this is to be the algae. Okay, this is the lake, or this is the coastal part. Okay, and you can see this is the bluish color water is there. So this bluish color, bluish radiation is come out, emission of light is come out due to some reaction in occur into the algae. Okay, this is the algae. Inside the water there are algae, and it is oxidized and it produces the light. Okay, so this is to be the bioluminescence is there. Then some jellyfish also gives luminescence. So this is called as also be the example of bioluminescence because of some proteins. Okay, because of protein it gives the light. Okay, again you can see this is the interior part of the ocean. It's very colorful and very beautiful. Light come out from this. Okay, so these all are the bioluminescence because there is biological reaction is there, and in a living organism occur the some reactions and in which that light is come out. So this is called as the bioluminescence. Okay, so for your kind of information you have to keep in your mind this Osamu Shimomura. Osamu Shimomura is a Japanese scientist. He firstly find out the GFP protein in a jellyfish. Okay, means the jellyfish it gives colorful light. Jellyfish is the color, it emits colorful light called as a bioluminescence. This bioluminescence because of GFP protein. GFP protein is there. Okay, so due to that protein it gives colorful light. Okay, so it firstly identify Osamu Shimomura, and for his work म्हणजे यांनी डिस्कवर्ड केल्यानंतर कुठं बायोलुमिनेसन्स वरती वर्क सुरू झालं. ओके, बिफोर दॅट इट इज द डेड कंडिशन. दिस कन्सेप्ट बिकम टू बी द डेड कंडिशन. So beautiful reactions and beautiful concept occur in nature, but before the discovery of this Osamu Shimomura, this is to be hiding concept for the world. Okay, so it introduced, and for this work he was awarded by the Nobel Prize. Okay, he was awarded by the Nobel Prize, and this is the very beautiful concept. Because of this bioluminescence and chemiluminescence, our study become to be so easy. Discovery of science is very easy, and it's very easy to understand the various very small reactions, micro reactions. Okay, so let me see their applications. याचे ऍप्लिकेशन आपण पाहू शकतो. इथे बघा, सबसेल्युलर लोकेशन ऑफ फ्लोरोसन्स प्रोटीन सेमिरेज. ओके, म्हणजे आपण सेल जी बघतो इथे एक थोडासा मोठा चेंज लक्षात येईल आपल्याला. देयर आर माइस, है ना, and you can see this greenish mice are coated with the bioluminescence, है ना. याच्यावरती बायोलुमिनेसन्स लावले आणि याच्यावरती बायोलुमिनेसन्स लावलेले नाही आहेत. and you can observe this in dark conditions. So you can observe here, you can identify this mice very easily rather than these three. Okay, लक्षात येत आहे. हे बघा, यांना आपण पाहू शकत नाही अंधारात क्लिअरली, पण यांना एकदम क्लिअरली पाहू शकतो. सो दिस इज द इम्पॉर्टंट ऑफ बायोल्युमिसन्स इन द स्टडी ऑफ सायन्स. आणखी पाहू आपण थोडं डीप मध्ये. पहा इकडे आपल्याला मायटोकॉन्ड्रियाला जर पाहायचं असेल तर त्या सेल वरती जर तुम्ही आता बायोल्युमिसन्स जर लावला किंवा केमिल्युमिसन्स कंपाऊंड जर लावलेत तर काय होतं, यू कॅन सी हिअर मायटोकॉन्ड्रियाला तुम्ही एवढ्या क्लिअरली इथे पाहू शकता. ओके, मायटोकॉन्ड्रियाला. त्यानंतर हे आणखी सेलचे पार्ट आहेत, ते तुम्ही जास्त समजू शकता बिकॉज यू आर द मायक्रोबायोलॉजी स्टुडंट. देन टॅबुलिन, ओके, त्यानंतर गॉल्गी, ठीक आहे ना, वेनिकुलन, असे खूप सारे पार्ट जे आहे, हे स्टोन है ना. त्यानंतर हे खूप सारे पार्ट आपण इथे ऑब्झर्व करतोय. मी काही स्लाइड फोटो घेतलेले आहेत, हे ऑनलाईन फोटो घेतले आहेत, तुमच्या चॅप्टर मध्ये असेल. But you can understand what is the importance of bioluminescence. Okay, this type of luminescence, how it important. Okay. Then lastly, I am show you this slide in which you can see even human body also gives luminescence. It also gives luminescence. So for that, one experiment is carried out by the Hitoshi Okamura. ये सर्कॅडियन बायोलॉजिस्ट, ओके, कायटो युनिव्हर्सिटी इन जपान. म्हणजे जपानमध्ये यांनी परत एक एक्सपेरिमेंट केला की ठीक आहे, जेलीफिश किंवा आणखी लिव्हिंग ऑर्गॅनिझम रेडिएशन लाईट इमिट करतात, बट ह्युमन बॉडीच्या वरती रिसर्च केला. अँड फ्रॉम दिस रिसर्च ही स्टेटेड दॅट की ह्युमन बॉडी सुद्धा रेडिएशन लुमिसन्स देतात. ओके, तर हे एक आर्टिकल आहे, ते सुद्धा तुम्ही वाचू शकता आणि यू कॅन बी अंडरस्टँड द इम्पॉर्टन्स ऑफ बायोल्युमिनेसन्स अँड केमिल्युमिनेसन्स अँड फ्लोरोसन्स अँड फॉस्फोरसन्स. ओके, त्याच्यासाठी काय केलं त्यांनी, याला कंटिन्युअसली इथे पाहू शकता आपण. कुठली एक बॉडी होती, त्याला आपण एक लाईव्ह बॉडी, जिवंत म्हणू, त्याला इकडे लाईट वरनं बंबार्डिंग झालं आणि मग नंतर डार्क रूम मध्ये त्याला ठेवलं, अतिशय डार्क रूम मध्ये. तर तिथे ऑब्झर्व झालं की त्याचं रेडिएशन जे आहे की तिथे सुद्धा अशा टाईपचे त्याचे लुमिसन्स तिथे पाहायला भेटले. ओके, आणि याच्यामध्ये आणखी एक गोष्ट जर बघितली की इट लोवेस्ट पॉइंट ऍट द 10 AM, मॉर्निंग मध्ये कमी तिथे तुम्हाला लुमिसन्स पाहायला मिळाले. अँड ऍट द 4 PM है ना, जसं जसं इव्हिनिंग कडे होत गेलं तसं त्याचं जास्तीत जास्त लुमिसन्स, डार्क लुमिसन्स पाहायला मिळतं आणि कम्प्लिटली बॉडी लुमिसन्स करते, हे सुद्धा आपल्याला इथे पाहायला मिळते ड्यू टू द मेटाबॉलिझम. ड्यू टू दी मेटाबॉलिझम, बिकॉज इन अवर स्किन देर इज अ मेलॅनिन इज अ प्रोटीन. ओके, मेलॅनिन असतं आपल्या बॉडीमध्ये आणि ते मेलॅनिन काय करतं, एनर्जी अब्सॉर्ब करतं आणि मग तिथे रिॲक्शन होऊन काय होते, एनर्जी तिथनं हे असं इमिशन, लाईट ऑफ इमिशन तिथं बाहेर निघतं. आणि फ्रॉम दॅट this emission is observed in dark room, so it observes such a type, it gets such a type of pictures. Okay, so this is the one of the very beautiful research by this Hitoshi Okamura and also by the Masaki Kobayashi. So you can read this, हे तुम्ही वाचून घ्या, नेटवर सर्च करा, याच्यावरती आणखी रीड करा, and you can understand in detail morely, deeply you can be understand to the luminescence and fluorescence and phosphorescence. So these all are the related to the photochemistry. Okay, so in beginning there is a very sad face I show to you. So don't think about the sad faces in the starting of this chapter, but now we are come to the end of this chapter. So I hope everyone get this knowledge about the photochemistry, and that is must to be useful for you, and it is very easy to understand because this photochemistry is most important and you can see everywhere. And it creates the beauty in nature due to the photochemical reaction. And we all living organism can be live, we can be move, we can be do any work is only because of photochemical reaction. Because if there is no photosynthesis in the world, so there is no any plant can be live. And if there is no plant in the world, so you cannot get O2, means without oxygen you all or we all will be die. definitely will be die. And if there is no carbohydrate is formed by the molecule, uh, carbohydrate molecule not formed by the plant, if there is no photosynthesis in the plant, so there is no food come, there is no production of food, you know, there is no food. Okay, so without the food and without the oxygen we cannot be live. So that's why it is a very much important role of the photochemistry in our life. Okay, so also you know that vitamin D formation is also the photochemical process. That's why very people they recommend to us to stay or take the light in morning from the sun. That means it helps to formation of vitamin D, and also so many reaction is there that help to our health and also for our happy life. So that's why after studying this whole chapter, definitely I hope your face like this, and like this big smile come on your face. I hope to that. And if you have any query, you can ask me and try to understand to photochemistry, read it and search the various example, various various matter about the photochemistry, and you can be understand the what is the role of photochemistry in our syllabus and also in our life. Thank you very much. Okay.